ठीक है, चलिए क्वेश्चन देखते हैं। एंटी साइक्लोनिक कंडीशंस आर फॉर्म्ड इन विंटर सीजन व्हेन एटमॉस्फेरिक प्रेशर इज हाई एंड रेन टेम्परेचर्स आर लो। ठीक है, पॉज करना वीडियो, खुद से क्वेश्चन को सॉल्व करने की कोशिश करना, देन देखना कैसे मैं अप्रोच करता हूँ। देखो जी, ये तो सबको पता है कि एंटी साइक्लोन बनता है आपका फ्रंट से। यहाँ कोल्ड वेदर होगा, यहाँ कोल्ड एयर होगा, एयर मास, यहाँ वार्म एयर मास होगा। यहाँ पे जेट स्ट्रीम होगी, हाई प्रेशर जेट स्ट्रीम में बनेगा ऊपर, यहाँ पे हाई प्रेशर बनेगा, तो जाके नीचे लेवल पे एटमॉस्फेयर में लो प्रेशर होगा। यहाँ लो प्रेशर, यहाँ पे हाई प्रेशर, यहाँ पे विंड्स आएंगी, तब एंटी साइक्लोन बनेगा। ठीक है, दैट इज टेम्परेट साइक्लोन, ये तो पता है। अब इसी नॉलेज से हम देखते हैं क्या होगा। एंटी साइक्लोन कंडीशन ऑफ फॉर्म इन विंटर सीजन, हाँ जी, विंटर सीजन में ज़्यादा बनने की संभावना है, बिकॉज कोल्ड एयर विल बी मोर प्रोमिनेंट इन विंटर सीजन। ठीक है, ये करेक्ट हो गया। विंटर सीजन एटमॉस्फेरिक प्रेशर हाई रहेगा ऑफकोर्स। इफ देयर इज मोर कोल्ड एयर द एटमॉस्फेरिक प्रेशर विल बी हाई। मोर कोल्ड एयर will come down. If it will come down, then it will create more pressure. ठीक है, air pressure are low, air pressure are low, air temperature are low, high pressure temperature will be low of course in winters. ठीक है, this is correct. Winter rainfall in northern India causes development of, हाँ जी, western disturbances in North India causes disturbances. Exactly, let's go here. Okay, so this is North India. In winters, the ITCZ, this equator, this thing shifts here. Okay, normally westerlies run from here, normally here. Okay, but in winter season, this Tropic of Cancer's high pressure belt comes down, and hence westerly runs from here, picking up moisture from Mediterranean Sea. So this is high pressure belt. Above would be low pressure belt, and here it would be frontal rainfall, and this frontal rainfall causes rainfall in winters in India, northwestern regions. So western disturbances are nothing, they are just anticyclonic or frontal rainfall or temperate cyclone causing rainfall in India. So both the statements are correct, and this is a correct explanation as well. Answer is A. Okay, now next, this winds, let's do it. Pause and do it yourself and then see how I'm doing. Phone and Chinook are snow eater winds. Okay, so phone is from Europe. 4. Samoon, no idea. Santa Ana, California. 3. Zonda, Argentina. 5. So if you see this as North America, 4 most important winds are there: Chinook, Santa Ana, northeaster blizzards, and black roller. If you see, this is black roller, this is Santa Ana, this is your Chinook, this is northeaster blizzards or blizzards, this is South America. Here Zonda, Pompero, and Virasena. Zonda, Pompero. Let's see this. Here you go. You see this? Santa Ana, Zonda, Argentina, and Chile. Okay. Next. Now Kurdistan. Where is this Kurdistan? So Kurdistan is a conflicted region in Syria. Not in exactly Syria. It is Kurdistan are the mountain tribes of Arabian Peninsula. Now what they do? Where is the location? Conflicted zones, and here is Kurdistan. This is Kurdistan. So they claim this entire territory. So they live Kurdish people live in Syria. It was in news. Syria, Iraq, Iran, Turkey, majorly here. Some of them also claim Armenia. So these regions they claim. 1, 2, 3, 4, 5. This was in news because of Yazidi, Quds and Turks. This is Quds. Yazidi, one of the Yazidi girls got Nobel Peace Prize or something. So that is why this was in news. Kurdistan. Look at it very carefully. Try to remember it. Try to make it in your notebook. Kurdistan, Syria. They fought ISIS as well. USA supported them to fight ISIS. Okay. Next. So this would be B is 2, A is 4, Zonda is 1, so D is 1, B should be the answer. Okay. Now next. Yes, stormy weather. Sorry. Which one of the following weather condition is indicated by sudden fall of barometer? You see, barometer we have read. Barometer is there to read pressure. If barometer falls, that means pressure has fallen, low pressure. Barometer down, pressure down. Now sudden fall. Now pressure down, first of all. Pressure down, it means that warm air has risen up. That means it will be rainy, thunderous, no calm weather, no cold weather. So either it would be A or D. But sudden fall, it will indicate stormy weather. This you have to remember. Okay. There are two kinds of barometer. One mercury barometer and one aneroid barometer. It was the first sentence in, you see, here, you see, mercury barometer and aneroid barometer. Okay. Now next. What is this? Roaring 40s. Okay. They blow uninterrupted in southern and northern hemisphere. Pause and do the question yourself and then see the video. They blow uninterrupted in the north and south. No. Only in south hemisphere. These are the winds. Roaring 40s, furious 50s, screeching 60s. These are the winds that blow very fast in southern hemisphere because there is extremely low amount of land mass in southern hemisphere. That is why they do not encounter a lot of resistance due to land, and hence they are very fast. They run in west to east direction because they come under the influence of westerly winds. Okay, so this is wrong. They blow with great strength and consistency. Their direction is northwest to east in southern hemisphere, west to east. Overcast sky, rain, raw weather are generally associated with them. Okay, this is a good question. Now let's go and see this. Here you see. Just focus on this. 40 degrees, 40s, 50 degrees, furious, 60 degrees, screaming 60s. Now let's go and see a world map. Isobar. Here. You see? Direction of wind. No landmass, 60 degree, nothing. 50 degree, little of Argentina. In general, nothing. 40 degrees, some of Argentina and Chile. Nothing, 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 nothing. Some of New Zealand. So this is virtually no landmass in 40, 50, 60s. And in only 40, 50, 60s it will run because it is aided by westerlies. After 60, 65, easterlies will come from down in this direction. So these winds will not be able to move this fast. Okay. This is the case. Again, let's see that diagram. You see here till 60. After that, direction is like this. So hence, no fast movement. Next. Again, difficult question. Pause the video and see if you can do it. Which of the following areas as ABC given? cyclone witness heavy torrential short duration rainfall, heavy rainfall. You see, I've told you, in anticyclonic conditions. From here, cold air comes in, cool air. Here, warm air pushes. So this is a symbol of warm front, and this is a symbol of cold front. In cold front, as cold front moves fast, it will create cumulonimbus clouds, high clouds. High clouds will create heavy rainfall. In warm front, it will create layered clouds, strato clouds. Strato clouds will give less rainfall. It will not give a heavy torrential rainfall. So according to me, the answer should be D. Here it will be torrential rainfall, but they have given B. It doesn't really matter, but you must remember that here less intense rainfall at A, intense rainfall, and at B more intense rainfall. Let's see the diagram. Warm front. You see, warm front. Warm front means cold air is lying here. It is not moving. Cold air mass. Warm air mass is moving towards cold air mass. It is going above it, and hence these type of strato, strato, strato. Okay, so layered clouds are formed, not extreme rainfall. No. Now, in cold front, cold air is moving towards warm front. Cold air has more speed, it is more dense, and hence cloud formation is cumulonimbus. Now see this. This is the difference between warm front and cold front. Read it. See, warm front intensity would be low. They are generally less intense. Cold front, they are more intense. Okay, pause and read. Next question. This is page number 129. Here we are at 126, 127, 131. This question now. Willy. Pause and read. So there are four types of cyclone. Name of cyclones. There are four names of cyclone. There are four names of cyclone. If you see. There's Australia. Here is India. Here is Japan, South China Sea. And here is North America. So when cyclone comes near North America, it is known as hurricane. When cyclone is in South China Sea, China, Japan, it is known as typhoon. When cyclone is here, that is east of Australia, it is known as Willy. And when cyclone is India, it is known as cyclone. So these are the four names of cyclone. Okay, let's go there and see here. Cyclone. Here, this diagram. This is cyclone. Typhoon, cyclone, Willy, and hurricane. That's it. Okay. Now, one more question. Let's do a question and then you will get it. Willy. Willy. Hurricane. This question. Solve this question. Pause and solve this question. Now next. This is done. Next question would be 31, 34, 31 done, 34, page number 34. Now this question, again, easy question. If you see, which of the following is not a planetary winds? Planetary winds are those winds which run on the planet Earth throughout the year. So there are only three types of planetary winds: Earth, equator, 23 and a half, 66 and a half, 23 and a half, 23 and a half, 66 and a half. Towards equator, trade winds, northeast and southeast. Away from tropics, westerlies. Away from poles, easterlies. So this is easterlies, this is westerlies, and these are trade winds. Trade winds. So these are three types of planetary winds. Rest, monsoon. Monsoon is a seasonal wind. It is known as a reversal of wind. So that's it. Now here, and again diagram. This diagram. See carefully. Northeast trade winds, southeast trade winds, westerlies, westerlies, easterlies, easterlies. These westerlies are slow because it encounters land a lot. There's a lot of land mass in the northern hemisphere between 35 to 60. In comparison to northern hemisphere, southern hemisphere does not have a lot of land mass, hence it is less resistance, and hence speed is more of westerly. Okay. Next question. Westerly, easterly, okay. Again, same story. Roaring 40s. Pause and do it. In the region between 40 to 50 degrees south, where prevailing westerlies blow in open sea with great and regular speed. Done. No. Next question. Trade winds. Again. Pause and do. Revolution of Earth, not really. Rotation of Earth, not really. Insolation will cause trade wind. You see now, there is less insolation at the tropics, hence high pressure. There is more insolation in equator, low pressure. That is why wind move from here to here. In flowing movement of air along Earth's surface towards equator, this is the correct answer. The wind is moving towards equator, but caused by no. Cause is variation in insolation. This would be a better reason. This is not a good reason. C. Now next again, which is not correct. Doldrum, as you see. This is a low pressure zone. Why? Because wind converge here. Wind from here comes and they rise up. They will rise up. And convergence of wind. Little wind or absolutely zero wind in this region. 0 to 5 degree north and south. North and south. No wind because of low pressure. Everything will go up. Nothing will be in horizontal motion. So no wind. Okay. So low pressure zone, correct. Low pressure zone with calm weather. Same situation occurs at horseshoe latitude, subtropical high pressure zone. Wind will come from here and it will diverge, but there will be less wind in this region because everything is coming and diverging. Hurricanes are wind having a mean velocity of 100. No. Grade 1 hurricane 120. Minimum 120 km per hour is required for hurricanes for a wind to be called as hurricane. New Moor Island, Bay of Bengal. I will show you the picture now. Alluvial run of Kutch. Yes, alluvial soil is found in run of Kutch. Let's see some pictures. Soil. Geography. Indian geography. Yes. If you see carefully. Alluvial. Can we find alluvial in run of Kutch? We can find. This is run of Khambat. In Khambat, this is Kathiawar region. In Kathiawar region, there is no alluvial, but here we can find alluvial. Okay. Moor Island. अरे आजा. Moor Island. You see, this is New Moor Island. Two rivers you can see: Ray Mangal River and Haribanga River. So Moor Island, there's a conflict in Moor Island between Bangladesh and India. India claims it to be itself for itself, and Bangladesh also claims it is uninhabited island. Nobody lives there. Okay, so this is what Moor Island is. Now where are we? कहाँ गया? अरे ठीक है, डोलड्रम हो गया, हरिकेन्स हाँ. ग्रेड ऑफ हरिकेन. माइल्स नहीं चाहिए. Here it is. इसको वहाँ चिपका देता हूँ. कहाँ गया? Here you go. Now you can see category 1 hurricane. 119 is the speed, minimum speed. So this is what hurricane is. The scale is known as Saffir-Simpson hurricane scale. Grade 2. You don't have to remember grade 2. Grade 1, that's it. The maximum it can go anywhere. So grade 1 and this scale. That's it. Now next. Doldrum, again same story. Pause and do it yourself. Calm weather, light wind near equator. A is the answer. Now next. That's it. Over. This is over. Now let's go to your CAPF questions. Here. What is it? Pause and try to do it yourself first. We are talking about winds. They occur in upper level of the atmosphere. Achha, let's see the options first. Identification. Jet stream, westerlies, geostrophic, easterlies. Upper level of the atmosphere. Jet stream is upper layer, geostrophic upper layer. Over. They are subject to two forces, pressure gradient force and Coriolis force. Okay. The forces balance and air moves at a right angle. Yes, air moves at a right angle. Geostrophic wind. ठीक है, जियोस्ट्रॉफिक विंड फिर से देखते हैं हम. कहाँ गई जियोस्ट्रॉफिक की कहानी? ये रही जियोस्ट्रॉफिक. ठीक है, पॉज एंड रीड इट. Pressure gradient. The air will move from high pressure to low pressure and it will jump across isobars. So the pressure gradient will be like this. The air should also move with pressure gradient, but unfortunately due to Coriolis force the air is pushed perpendicular to the isobar, but it does not move perpendicular, it deflects towards the right in the other hemisphere because of Coriolis force. So now pressure gradient is here, deflection is this, and perpendicular to deflection or perpendicular to pressure gradient is your Coriolis force. So this will go. You see, the amount of deflection increases and hence this angle is also increasing. Deflection increasing, angle increasing, and at a point the deflection will be parallel to the isobar and the angle will be straight. So this is why we see geostrophic wind at higher latitude, because it takes a lot of speed for wind to be parallel, deflection to be such that it is parallel, and hence the pressure gradient and the Coriolis force is uh, perpendicular to each other. Okay, or at 180 degrees. Next, hailstorm. Pause and read. Not correct, they have asked. So you should find correct. Go for correct. Hailstorm. You know that diagram. That because of thunderstorm, updraft and low draft, hailstorm is caused. Warm air will move up. It will moisture H2O vapor will convert into H2O, and hence these droplets will go up and up and up and up. Ice crystal up and up and up and up. It will turn into snow. Go up and up and up. The snow will be so heavy that it will not be able to move up. Hence, it will come down. So if you remember thunderstorm, there is updraft of warm moist air. There is downdraft of cold air. So this updraft and downdraft will create thunderstorm. Particles of warm air and particles of cold air will mix together, will interact with each other and cause thunderstorm. So hailstorm will occur with a thunderstorm because hail is a phenomenon of downdraft and moisture is a phenomenon of updraft. This is what you should remember when you see hailstorm, that video, and then you would be able to solve this. Now you see hailstorm is not correct. They form usually, their formation usually occur during monsoon season. This I have not told. So question mark. Now next, they are associated with a dense cumulonimbus cloud. Yes, cumulonimbus cloud, because in thunderstorm we have seen cumulonimbus cloud. Rains that form in warmer, lower level, of course, solidify into tiny ice petals or hailstorm in upper subfreezing layer. Correct. Hailstorm has a multiple concentric layers of ice. Correct. This is wrong. Usually, hailstorm occurs in pre-monsoon season, not in monsoon. Why it occurs in pre-monsoon season? Because there is comparatively colder upper atmosphere and warmer lower atmosphere. In monsoon season, both the layers of atmosphere are not at a high temperature difference for thunderstorm to form or hailstorm to form. Okay. So let's go to hailstorm. Hailstorm. Pause and read these four conditions and you will understand. Read this entire, pause and read. Now next. Climatology. This is done. A. Now next, 53. Pause. Regarding the temperature on the Earth's surface. What is it? The temperature of the Earth's surface is determined by net radiation. What is this net radiation? First, you have to understand this. Incoming solar radiation and terrestrial radiation. So, when the solar radiation will come in, this is incoming. When the Earth will reflect back this radiation to the atmosphere, terrestrial radiation, this is an outgoing. So, difference between incoming solar radiation and outgoing solar radiation is known as net radiation. Okay. The temperature of the surface is determined by net. If it is more reflective, the surface is more reflective, then it will be warm, it will be cold. If the surface is less reflective, it will be warm. Okay, so this is correct. Net radiation produces radiation energy flow that heats or cools surface. Correct. Net radiation balance is usually positive during daytime and negative during nighttime. Positive means incoming is more than outgoing, which is correct. In daytime, we witness more sun rays, and in nighttime we witness more terrestrial radiation. The Earth's surface releases back heat. All three is correct. Now, soil surface loses energy as temperature increases during daytime. Of course, you see this. This is a confusing point. Let's just suppose this is soil. Soil. The sun is at 20 degrees. It is coming down, coming down, coming down. At 20 degrees, let's just suppose 100 units of solar radiation Earth is receiving. So Earth will reflect back, let's just suppose 50 units. Okay. Now I have increased the temperature 30 degrees. Now 150 units, 150 units is incoming. So outgoing would be certainly more than 50. Outgoing would be, let's just suppose 60. So it is more. That is why this statement is correct. Soil surface loses energy as temperature increases. As temperature went from 20 to 30 during daytime, it is losing energy. It is radiating more energy. Usually try to find out an example of complex sentences, especially in logical subjects such as this, such as geography, economy, science and tech, and environment. Try to find out example and see a broader meaning of that sentence. If you see a broader meaning, then only question will be solved. Otherwise, you will do C. The answer is T. Okay. This is also in NCERT. Net radiation here. It is in chapter 9. Chapter 9. This is net radiation. You see, net radiation balance. This is from where the question has come. Your understanding should be there. Now next, trough and ridge. Very interesting. There are three ways to do it. Three conditions. Okay. First, there is trough versus ridge. Second, similar thing, trough versus crest. Third, anti-syncline versus syncline. All three have same diagram. You see, ridge is something which is upwards. Ridge, mountain ridge. This is mountain ridge. Two mountains are matching. This is ridge, so which is upwards. So this is ridge. This is turf. Okay. Downward slope. Turf, ridge. Turf again. This is crust. Anti-syncline, syncline. Sink. We are sinking in. Sink, and then anti-syncline is A. So if it is A, it will be up. So these three terms, six terms rather, are same. This represents up, this represents down, this represents up, this represents down, down, up. Okay. Now let's do this question. Pause and do. Turf, down. Down means low pressure. Ridge, up, high pressure. A answer. Next question. Pause and do. Normal lapse rate. As we move up, temperature decreases. Watch is at what rate it increases. You see, if we have gone 165 meter up, temperature will be reduced by 1 degree Celsius. If we have gone up by 1 kilometer, temperature will be down by 6.5 degrees Celsius. This is normal lapse rate. The answer would be A. Next. Pause and do. The jet stream are high altitude. Easterly, they are high altitude, correct? But they are westerly, over. El Nino, warm ocean temperature, yes, warm. El Nino in Peru coast, yes, correct. I'm explaining both of this. Again, El Nino, La Nina. You see, El Nino occurs when the trade winds are slow. So trade winds are slow here. Warm water will move till here. After that, the trade winds will not have the capacity to move these warm waters to the South China Sea or India. So the warm water will recede backwards, and here it will do the warming. This is Peru, this is Chile. So warm water will accumulate near South American coast because of weakness in trade winds. Okay, so this is known as El Nino. Now let's go back. El Nino, warm current, correct. Peru, correct. 2 and 3 is the answer, B. Next. Doldrum, again same condition. Equatorial calm, correct. Calm weather, correct. Roaring 40s, no. Variable position, yes. As sun moves, ITCZ also move, and hence the doldrum This low pressure belt of 0 to 5 degrees will also move along with sun. This is done. Now, very difficult question. You will have to remember this, otherwise you won't be able to solve it if it repeats. You see, which one of the following is not a paleoclimatic geological? Paleo means old. So which one of the following does not tell us, is not able to tell us about the old climatic conditions of Earth? You see, Laxtarine deposit. Laxtarine means lake deposit. So lake deposits tell us about earlier climate? They can. Ice sheet, ice core. Ice can also tell us about old climates. Evaporites. Any element on the Earth's surface. Let's just suppose this is land or a rock. When all the water has been drained out of this element, the remaining part after draining of water that remains are known as evaporite deposits. Again, it will sedimentary rocks, of course, it is made up of sediment deposit. It will also tell. Answer is B. Why? Because ice sheet does not tell us about paleoclimatic condition, whereas ice core will tell us. Now next, in mid latitudes region, diurnal variation is there. Again, from NCRT, direct line is from NCRT. It is in notes as well. यहाँ जाना है, यहाँ आना है और जाना है मुझे एडविक्शन पे, यहाँ पे आना है. Right. हाँ, ये रहा एडविक्शन. This is chapter number 9. Okay, chapter number 9 has advection. Here you go. In mid latitudes, most of the diurnal day and night variation in daily weather are caused by advection alone. Okay, why is this? Why advection? You see, in mid latitudes, that is 23 to 66.5 degrees Celsius, there are only three ways to transport heat: conduction between layers and layers, convective cells, air moves up, cools down, comes down, convective. So these two, conduction and convection, are not readily occurring in the middle latitudes. Why? Because there is not a lot of insolation. So the rising of air is not very effective in mid latitudes. So how will air move then? Air will move horizontally. Air masses, not just air, entire mass of air will move. Cold mass and warm mass. And this is why, and this movement of mass is helped by advection. That is why advection occurs, because insolation is less in mid latitudes, and hence convection and conduction. Transport of heat through convection and conduction is less, and transport of heat through advection is more. Okay. Now next, this is done. Arabian Sea. Pause and read. Arabian Sea, highest salinity. You see, this is India. This is Arabian Sea. This is Bay of Bengal. Let's just suppose Indian water mass has 20 parts of salt per 1000 liter of water. Okay. But if you remember that in Bay of Bengal, most of the freshwater rivers drain into Bay of Bengal. Hence, it will be 20, but water quantity will increase 1500 water in Bay of Bengal. Hence, density will come down, salinity will come down. In Arabian Sea, less fresh water is draining, so it is 20 divided by 1200. Salinity is more as compared to Bay of Bengal. Okay, this is chapter 13. When we'll go to that chapter, then I will explain you better. This is done. Now next, again this question we are skipping. We will do it in chapter 12. Now next, 62. Lowest temperature is recorded in mesosphere. How? Again, diagram. Chapter number 8. If you see this diagram very carefully. You see, we are going up in troposphere. This is 20 degrees. We go up. As we reach to tropopause, the temperature is minus 60. Okay, temperature is decreasing as we are going up in troposphere. Now, this is pause. This is similar temperature in this region. Then in stratosphere, we started at minus 60. We going up. We ended at almost 0. So as we go up in stratosphere, the temperature is increasing, okay? Because it is interacting with UV radiation. That is why temperature is increasing. Now stratopause. Again, in mesosphere, we are at 0. As we go up, the temperature is decreasing. And now you see the temperature is minus 80. None of the layers has such a low temperature. This is around almost minus 80. This mesopause minus 80. And then as we go up in thermosphere, it is temperature is increasing like stratosphere. That is why mesosphere has lowest temperature. Okay. Now next question. So this is done. Okay, last question. Tropical cyclone. Pause and read. It originates and develops over warm surface ocean. Exactly. SST. Sea surface temperature must be 27 degree and higher. Presence of Coriolis force. Yes, presence of Coriolis force is necessary. That is why near South America, here and here, no tropical cyclone. Because ITCZ is near equator, hence no Coriolis. Correct. Mid latitude snow. It occurs in 5 to 20 degrees latitude. And if the cyclone is forming above 20-degree latitude, it will recurve because it will come under the influence of westerly, especially during winter season. Okay. Now development of eye with calm. Yes, eye is calm, temperature is high, pressure is low, no rainfall. Correct. This B. Done. Now let's go to cyclone. Pause and read cyclone. Cyclone. Conditions for cyclone. Yeah. Coriolis effect here. Tropical region. Warm water. Rapid cooling with height. As this moves up, air moves up, it should rapidly cool. That is why if it will rapidly cool, vapor will convert into H2 and it will release latent heat of condensation, that is heat, and that heat will come into the eye of the cyclone and will come down and hence accentuating the low pressure. There will be more low pressure as the heat will come down. Correct. High humidity, of course, high humidity must be there. If there's more humidity, then only condensation will happen. The air must be saturated with water vapor. That is why if it is given more water vapor, it will turn that water vapor into liquid. High humidity is required. Vertical wind shear is required. If in the vertical sphere, if the wind is moving at 5 km, it should constantly move at this speed. Otherwise, the cumulonimbus cloud, which is formed here, will be dispersed. It should move in a constant rate, or it should be very low. So low wind speed should be there, meaning it should not change direction, should not change speed. It should be in a uniform speed. Now disturbance, there should be existence of low pressure. ITCZ is required. Low pressure zone is required. Okay. These are the stages. Once pause and read. Okay. This is your cyclone. This is eye and eyeball. Pause and read. Now we'll see you in next class. Bye bye.